For 15 years, your files, apps, and storage disappeared into someone else's cloud. But right now, artificial intelligence is reversing that entire trend. If you want a truly useful AI agent, it can't live isolated in a browser tab. It must read your messy folders, edit your spreadsheets, inspect your code, and remember your decisions. It has to touch the actual work. We've actually been here before. Before personal computers, the dominant model was time-sharing. You rented compute on someone else's mainframe and waited in queues to get anything done inside rules set by an operator. That changed when machines like this Apple II arrived. They didn't win because they beat the mainframe on raw power. They won because they collapsed the distance between the person and the machine, right there on the desk. AI is creating an identical opening. Most personal work isn't a moonshot benchmark. It's messy, repeated, and context-heavy. Intelligence is most useful when it operates in the exact location where your private work actually lives. Running AI locally requires purchasing your own hardware, but navigating the options right now is overwhelming. The biggest mistake you can make is buying a really fancy computer whose only job is to run benchmark prompts or do your emails. That wastes the machine's potential and your budget. You need a mental model for the entire AI stack: the machine, runtime, models, and memory. The hardware layer at the bottom creates a permanent bottleneck, constraining memory capacity, bandwidth, and the software you run on top. Currently, 3 dominant hardware architectures are competing for the space on your desk. Choosing an architecture that clashes with your daily workflow turns a powerful local AI tool into a punishing permanent IT maintenance project. First is Apple's high-end desktop line. A recent Mac with enough unified memory, like this Mac Studio, is often enough to start. The primary advantage is unified memory. Unlike traditional PCs, your CPU and GPU share one clean pool of memory, allowing massive data efficiency. Configured with hundreds of gigabytes of memory, you can hold gigantic context windows and massive private document libraries simultaneously. It's also power efficient and low noise. The machine feels like a standard computer instead of a science project. The trade-off is raw tensor throughput. Compared to high-end workstation graphics cards, Apple Silicon is significantly slower at pure processing. You also have a software limitation. You are largely tied to Apple's MLX framework, sacrificing access to the bleeding-edge developer tools built for NVIDIA. This path is best if you prioritize massive memory capacity and simplicity over raw speed and developer experimentation. The second option is the enthusiast route, building a custom PC tower housing multiple high-end consumer GPUs. This ecosystem centers on hardware like this modern RTX card, which is built for raw performance. The benefit is muscle. You get the highest processing speeds and superior throughput for heavy local inference. You also get a massive software advantage through CUDA. Because it's the industry standard, you have native compatibility with nearly every new model and tool. However, VRAM is sharded, or split across cards. To run large models, your data must be divided, which adds significant management complexity. Then there's the physical reality. A dual GPU setup generates extreme heat, draws massive amounts of power, and requires a lot of room. You also pay a continuous setup tax. Expect to spend regular time maintaining drivers, cooling systems, and your sharded memory configurations. This DIY path requires accepting a part-time job as a system administrator in exchange for absolute performance and access to the bleeding edge. The third option attempts to merge the best elements of both paths. The NVIDIA DGX Spark is an appliance powered by specialized enterprise silicon. It brings a massive, coherent, unified memory pool to the NVIDIA side, similar to what you'd find in a high-end Mac. It then pairs that memory with the native CUDA software stack, providing the speed of a PC workstation. This is a turnkey system. It offers enterprise-grade deployment and fine-tuning right out of the box, with zero DIY required. The catch is the cost. It carries an extremely high price tag and locks you into a rigid corporate product cycle. The appliance route allows users with high budgets to literally buy their way out of technical compromises, sacrificing modularity for perfect synergy. To find your ideal machine, we need to move past benchmarks and start sorting into 3 distinct profiles based on your real-world workflow. First is the local-first knowledge worker. You write, research, and manage sensitive documents that require a vast local memory store. You should choose the Mac. Your primary constraint is memory capacity to search through documents, not raw processing speed. Next is the local first builder. You're a developer running coding agents, testing products, and pushing high-volume repetitive tasks. You should build a custom RTX tower. For you, the heat and software maintenance are acceptable costs for raw developer throughput. Finally, the maximalist. You demand enterprise compliance, vast unified memory, and NVIDIA speed without building the tower yourself. If your budget allows you to ignore price constraints, the DGX Spark is the cleanest expression of the local thesis. There is no universal best computer for AI, only a routing system to match the precise technical friction you are willing to tolerate. As you build your stack, remember that the hardware itself is the least durable part of the equation. Models and the computer chips that power them will inevitably age out and be replaced within a few short years. Your true permanent asset is the local memory system, the accumulated notes, code, and transcripts that belong entirely to you. In the traditional cloud model, the service owns your data and you visit it on their terms. In the local paradigm, you own the core memory, and AI models are invited to access it locally. By using open databases like SQLite, your knowledge persists even as you swap out old models for new ones. Building a personal AI computer is a bet on sovereignty. Long-term intelligence operates over your life's work without requiring rent from the cloud.